Hi guys, welcome back to my channel. I Sujan of class 6M ISC Sri Venkateswara College of Engineering. Today we gonna talk about the decomposition based and call graph based and path based integration testing. And let us talk about what is integration testing. When we take four but let us consider we are building a one software. Okay, where when building a software, we cannot build all the units together and run together. Okay, so we need to first test the unit by unit, and later on we need to okay okay when we start when we uh, building in a software, we will integrate the steps, like when we combine two or three unit tests together, and then we will integrate them and we'll test together, and another we will take another three four, and those we will integrate and we will test together. Later on we will club everything, and later on we will integrate and we will test together. So this is about a basic information about integration testing, where for out of 4 to 5 decision or 4 testers, we will take few of them and integrate them, all the concepts of them, and then we will what we'll do, then we will test the remaining code and all. Okay, so let us see the next content. Decomposition. Okay, what and all the content we are going to study is decomposition based integration, call graph based integration testing, and path based integration test, as I told you before only. Okay, and now what is about a decomposition based integration testing? Okay, this is an SATM functional decomposition tree. Okay, in your left hand side, it is a diagram of an SATM functional. When we go to an ATM, we'll generally see the machine that has been linked to the bank, and there will be a key window and a screen window and a slot window. Another one is a data window. In key window, we will upload the password, and we will upload the password and all. And in slot window, we will insert our card, and the if card is everything is correct, and it will connect to the central bank, and then it will move to the money transaction. It's like when we go to the screen testing. Okay, is the monitor is working, is the person who is using the monitor is working properly. It's kind of a testing. And later on, when we go to the password entry, okay, if password is correct in the right pattern, or it is matching to the in card inserted you card which has been inserted by you, those and all the kind of testing. Okay, we took care as a ATM as an example. Okay, we can dispense with the big bang approach most easily. In this view of integration, all the units are compiled together and tested at once. Okay, let us talk about a big bang theory. Here it will lower the cost of a scaffolding by how it will wait all the integrate all the unit test to complete once, and it will merge all those test results, and then it will integrate to the system testing. Okay, here in big bang theory, the uh, outputs which are been sorry, the faults that have been find out at, that will be very costlier to in repair. So what we'll do in big bang theory, we will merge all the unit tests that we have been done, and we'll test them at once. Okay, so the drawback to this is that when a failure is observed, there are we fluest is isolate the location of the fault. Okay, and top down integration. Here top down integration being with the main program, the root of the tree. Any lower level at the is called as the main program, appears as a stub, where stubs are a piece of the thrown away code at the emulate a called unit. Okay, if we promoted top-down integration testing for the SATM system, the first step would be the develop stubs for all the units called by the main program. Okay, watch card slot, control card roller, screen driver, validate card, validate pin, manage, and transaction. Okay, as I told in that, what and all the testers, for example, testers has been done to the that SATM. Okay, the previous I have informed you that card slot and card roller, which is reading the pin, and screen reader and validation of the card, and manage transaction. Okay, this is a procedure. The above diagram is showing that what is the procedure and what if true and false, that is been saying that. Okay, once at all the steps for SATM main have been provided, we test the main program as if it is were a standalone unit. We could apply any of the appropriate functional and the structural techniques and look for it. Okay, now let us talk about a bottom up integration. Bottom up integration is a mirror image to the top down order. Okay, with the difference that steps are replaced by driver modules that emulate units of the next next level in the tree. Okay, in bottom up integration we start with the level of the decomposition tree and the units like control door and dispensation and we test them with specially code drivers. Okay, this is probably less throw away code in drivers that there is an steps. Okay, recall we had one step for each child node in the decomposition tree. Okay, most systems have a very high fun out the near. So in the bottom up integration order we won't have many drivers. This is partially offset by the fact that the driver modules will be more complicated, and we'll talk about when this top down and bottom up approach both will appear in the sandwich integration, where in sandwich integration both the things will be end at the middle of the in the step. Okay, sandwich integration is a compactable code bottom at the integration test. If we think about in the terms of decomposition tree, we are really just doing big bang integration on the steps 3. Okay, and now we are seeing how the big bang theory and sandwich theory are been mm, differing. Okay, now call graph based integration. One of the drawbacks of the decomposition based integration are let me take this up here. Okay, one of the drawback of the decomposition based integration is that basis is the functional decomposition tree. Okay, if we use the call graph instead, we migrate this deficiency. We also move in the direction of the behavioral testing. We are in a position to enjoy the investment we made in the discussion of the graph theory. Okay, since the call graph is a directed graph, why not we use it as the way we used program. Okay, program graph. This leads us to two new approaches to integration testing, well referred to a pairwise integration and a neighborhood integration. These are all the two types of the call graph. Okay, in call graph we will be having a instead of going to the decomposition based integration, we always prefer for the call graph based integration, because here the nodes are being directed and there will be a matrix that will be the matrix it will be having a matrix, and the paths will be directed. Okay, and it will be having a node. So and yeah, there are two approaches in integration in the new approaches in the to integration testing will refer to praise wise integration and a neighborhood integration. Okay, next one is a praise wise integration. Okay, the idea behind praise wise integration is to eliminate the steps or drivers development effort rather than develop steps and or drivers. Why not use the actual code at first? This sounds be like big bang integration, but we restrict session to just a pair of unit in the call graph. The end result is that we have one integration test session for each edge in the call graph. Okay, it's saying that the idea behind this is to eliminate the stubs and the drivers in the development effort, because the stubs and drivers will make a lot of difficulties in developing any integration test. Okay, rather than develop stubs and or drivers, why not we use actual code? Okay, at first this sounds like a big bang integration, but we restrict a session to just pair of units. Okay, just pair of units. So the end result is that we have one integration node session or each edge in the call graph. Okay, and next approach is the neighborhood integration. We can let the mathematics carry us the still further by borrowing the notations of a neighborhood from the topology. Okay, this is not much of the stretch graph theory is a branch of a topology. We we define the neighborhood of a node is a graph to be set of the node that are one edge away from the given node. In a directed graph, this means all the immediate predecessor nodes and all the immediate successor nodes are the successor nodes, the level neighborhoods of the SATM example based on the call graph. It's okay. And we are seeing the example of the this neighborhood and price wise. Okay. Here we can always compute the number of neighborhoods for a given call graph, where there will be one neighborhood for each interior node. Push one extra in case there are leaf nodes connected directly to the root node. Okay. We As I told that that predecessor and the successors have been connected, so we can always compute the number of neighborhoods for a given call graph. Okay. There will be one neighborhood for each interior node, plus one extra in case there are leaf nodes connected directly to the root node. Okay. As I said, there will be predecessor and successor that have been connecting. Okay. Then another one is a path based integration. Much of the progress in the development of the mathematics comes from the elegant pattern. We have a clear idea of where you want to go, and then define the concepts of that take you there. Okay. We do this here for a path based integration testing, but first we need to motivate and definition. When then units execute, some path of the success source statements is traversed. Suppose that there is a call to another unit along such as a path. At that point, control is passed from the calling control is passed from the calling unit to the called unit. Okay, where some other path of the source statement is traversed. The first guideline from path, the points of a Q sensor natural endpoints for an path. Our second guideline is used to server to distinguish integration from a system testing. Our second guideline, automatic system functions are an upper limit from path. We don't want to path to cross as a ASF boundaries. Okay. And there are two possibilities abundant: the single entry single exit preset, and treat such as call as an exit followed by an entry, or suppress the call system at because control eventually returns to the calling unit away. The suppression choice works well for unit testing, but it is unethical to integrate the testing. And lastly, thank you for watching the video, and I hope you have got some content to watch. And some things will be understand. Okay. Here. Thank you one and all.